So let's recap and then continue with our topic of growth. Now, we developed this production function here. We introduced a new classical production function with decreasing returns to scale, and we then looked at the links between output and investment, and crucially here we assumed Say's law, which means that all available savings are used, all resources are used to produce output, which means that we principally assume unemployment away, and from that we get that investment is just a constant fraction, with the further assumption that the savings parameter is constant. Investment is a constant fraction of output. Third, we looked at the link between investment and capital accumulation, and that gives us the all-important dynamic equation in per capita terms, so that here on the left hand side the change in the capital stock is equal to investment, which is this constant fraction of output f of kt from the production function, which is yt equal to f of kt. Let me do that properly and get yt equal to f of kt with constant returns to scale. That is this f of kt, and then last, depreciation. So the change in the capital stock is the difference between investment and depreciation. And third, and that's what we did not get done in the last video, is to develop a graph. That's what we want to do now. Well, I'll start out here with the production function. So let's just draw the production function, namely yt as a function of kt here, with decreasing returns to scale, so relatively steep initially, but the more capital we use per labor, the more output we get, but the increases become smaller and smaller. Now, how can we show this process here on the right hand side in this diagram? Well, excuse me, let's chart as well investment in this diagram. Investment is just a fraction s of production, so this here is fkt, then s of fkt is some fraction s. S must be between 0 and 1, so that is some fraction of this total product with the same shape, not drawn this very neatly, but with the same shape. This is equal to investment per worker. Investment per worker, and here on the top we have the production function with output per worker. Now, what is delta kt? Delta kt is the depreciation of capital per worker. Delta is a constant parameter and kt is the variable, so this is a linear function with a zero intercept, so that we're getting some function like that, delta kt. I'm going to write it on there, and we have a intersection between investment s of fkt and depreciation delta kt. That is the point that I've drawn here. Let me emphasize it. At this point now, how can we characterize this point? At this point, let's call it k star. At the point k star, we know that s of fkt is equal to delta kt, and if that is true, we know as well that kt plus 1 minus kt is equal to 0. So if the right hand side here, the difference is equal to 0, the left hand side is equal to 0, which means that there is no change in the capital stock. Remember that here this left hand side describes the change in the capital stock as a function of investment minus depreciation per capita, and hence when the right hand side is equal to 0, the left hand side is equal to 0, there is no change in the capital stock. So this is a rest point, it's an equilibrium, a steady state. That's what we call the steady state. Okay, how do we get there? Now, before I crammed all too much into this diagram, let me go to a separate page, namely this one. And I have prepared this little diagram here where we can see just a little bit better what's going on, and I want to show you one example of the dynamic adjustment that happens in this model. So let's assume that we're somewhere to the left here of what we know to be the steady state here. Let's call this K0. Now, let's understand what's happening here at K0. At K0, this is the level of depreciation. I'm going to call this D. At K0, this is the level of investment. I'm going to call that I. All of this in terms in per capita terms, but bear with me. Now, obviously, as you can see, the level of investment here is larger than the level level of depreciation, which means that, well, you guessed it, KT plus 1 minus KT is positive at K0, because S of FKT is larger than delta KT. That is this positive difference. So if excuse me, if there's a positive change in the capital stock, what's happening? Well, we're moving to the right here. On this axis, K, we're moving towards the right. If we're moving towards the right, what is happening in the next period is that YT as a function of KT will increase. So the production function, we are initially at this point, and as KT plus 1 minus KT is positive, KT increases, we're moving up along here to a new point where we have a higher capital stock. We could call it K1. Here we have Y0, and then we have Y1. Now at K1, Y1, this difference is still positive, so the process will continue until we are at this point. And at the steady state, so at K star, the system comes to rest, and the change in, let's do this in blue, KT plus 1 minus KT is equal to 0, because S of FKT is equal to delta KT. Now the same argument applies from the right hand side here. You see that on the right hand side, if you were to start here, depreciation is larger, so that this difference would be negative. Could include it here in blue, would be negative, so that this difference would be negative, so we're moving towards the left. We would be coming from this point along the production function to the steady state, and so we are approaching it from the right or from the left. Presumably we are on the left, since our capital stock is still increasing and we're experiencing income per capita growth. So I'll leave it at that, and we'll move on to another video.